All right, good morning. I'm going to do my standard waiting until I see that the stream has actually started. All right, I'm seeing the loading bar. I'm seeing myself. I'm going to check the audio. The audio sounds good. All right, good morning. I'm definitely going to be drinking coffee during this, so apologize for mouth sounds. I'll try not to slurp. This is a little bit of an experiment. I am just going to read this paper aloud and do the note taking that I would usually do with I'm that person. I like to print papers out. So I'm gonna, you don't need that, go through and do the note taking that I would usually do in the margins with a pen aloud by myself. And feel free to chime in if you have anything that's relevant or you have, suggestions. And I have a whole stack of papers that I want to read and just sort of haven't because, as it turns out, I'm not a grad student anymore and reading papers full time is no longer my job. So I've been getting behind and I was like, you know what? I can double task. I can make this my job. And this first one is one that is fairly closely related to some of my own research areas. So I've got a fair depth of knowledge in work in this environment, but I don't think I am familiar with other research from IBM in this sort of context. So the paper is Know Who Your Friends Are, Understanding Social Connections from Unstructured Text, and it should be, let me scroll down, you should be able to see the link in the description if you want to read along, and I'll also try to keep the visual big enough so that you can see it if you want to. And it's by Leah Delaris, Francesca Bonin, Elizabeth Daly, Stefan de Paris. Oh, that's an extremely French name. Yufeng Ho, Charles Joachim, Yassine Lassaud, and Kilian Lavache. So, and it is from IBM Research in Ireland, and this is a paper from this year. It was published at NACL, so the North American Association of Computational Linguistics Human Language Technologies Conference in New Orleans, which I wasn't at, but I am definitely going to be in the next one because I'm on the programming committee, so I should show up and do the work that I said I was going to do. Most of the work is going on now. And it's demonstrations. So if you're not familiar, demonstrations are more systems that you have that you want to show off, and less I'm developing new math that I want to share with people. So if you're not super familiar with NLP as a field, the premier place to publish your results is at conferences. So the fact that this is a conference paper is like, ooh, shiny, and not like, oh, conference paper, huh? Which is very different from other fields that I work in, like linguistics. So that's the background on the paper. It has been published. This isn't just like some randos on arXiv. Not that there's not good work on arXiv, but there hasn't been like an initial filter by people who know what they're talking about. All right, abstract. Having an understanding of interpersonal relationships is helpful in many contexts. True. Our system seeks to assist humans with that task using textual information, e.g. case notes, speech transcripts, posts, books, as input. Specifically, our system first extracts qualitative and quantitative information elements, which we call signals, about interactions among persons, aggregates those to provide a condensed view of relationships, and then enables users to explore all facets of the resulting social multigraph through a visual interface. So the idea here is that you can take in some text that you have and you can get out of it a social network. And if you're not super familiar with social networks, the idea is it's a graph in the sort of mathematical sense, where each node is an individual and edges between nodes are relationships between those individuals. So if I were drawing a graph of my social network, me and my husband would each be a node and there'd be an edge between us because we have a relationship, and my parents would both be a node and there'd be an edge between us because we have a relationship and we know each other, but there would also be edges with my husband because my husband knows my parents and we have a relationship that is social in nature, but I would also be connected to, it's not just familiar relationships, things like all my friends, all my acquaintances, and friends of my friends that I don't know, I wouldn't have an edge to, but I would have a connection to them through my acquaintance that I had. So it's a sort of general idea of social networks. It doesn't mean Facebook. Yeah, so this is interesting. I can see lots of applications for this. Clearly, commercial applications, but also this could be really nice for people doing like sociolinguistic field work to just sort of create their social network, because it takes ages. It takes so long. Yeah, let's keep reading. So the social network of a person plays a vital role in their well-being, providing access to assistance, resources, and support. Wellman and Wortley, 1990. And even influencing health. Christakis and Fowler, 2007. I'm not familiar with either of these papers. These are pretty old citations for a NLP paper, which means that they're probably citing the foundational work rather than sort of like someone who talked about it recently, which I like to see. If I don't see any citations older than like last year in your paper, that's a worrying sign for me. Understanding the quality of the social relationships beyond the simple existence of a relationship or its demographic nature, family or not. So in my example, my husband and I have a familial relationship. A friend of a friend does not. Provides a better perspective on the context and is essential in a variety of situations that extends beyond social media, such as criminal investigations, identifying suspects and acolytes. Oh, that must be a technical term. That might be from the British legal system. Sales, connecting the right person and target companies. Political analysis, understanding the evolution of alliances. And human resources, improving team dynamics. Yeah, so I'm going to be upset if I haven't read this paper yet, if later in the paper there is not a discussion of ethical implications and also sensitivity of their system. Because things like criminal investigations, I don't know if y'all are familiar with like gang databases. They're pretty popular. And some of the ones in California, which purport to contain gang members, have like infants in them. Infants are not gang members. So there's the potential here of building a system that might be applied in situations where it's not appropriate and creating problems for people. We'll see. Yeah, especially when you like lead off with law enforcement, my gut reaction is, you better have thought about this. All right. For instance, Yose, Y-O-S-E, et al., 2018, analyzed a medieval text to get novel insights into the hostilities during the Battle of Clontarf of 1041. Digital humanities. That's cool. That's a very benign and interesting and useful application of this technology. There are potentially not so benign applications. But let's get to the tech. The initial motivation for this work comes from the domain of social care. One essential task for care workers is to identify who plays a supportive or disruptive role in a patient's environment at a given time. Problems emerge when details get lost within notes of the multiple persons composing the care team. Significant details may have been recorded, but are locked inside free text narratives, requiring other parties to invest a great deal of time to gain a full understanding of the situation. Yeah, this comes up in sociolinguistic fieldwork as well. In this paper, we present a system designed to assist humans with the understanding of interpersonal relationships. Specifically, the system takes as input a collection of texts and automatically extracts a multi-graph representation of the relationships and their quality. From that information, we provide an interface to enable users to gain insights into the relationships, form aggregated information to fine-grained analysis, we provide an interface to enable users to gain insights into the relationships from aggregated information to fine-grained analysis of temporal patterns and emotion. So this is going to be a dynamic graph that's showing change over time. And I'm not entirely sure what a multi-graph representation is, so I'm going to Google that. A multi-graph is a graph which is permitted to have multiple edges, also called parallel edges. That is, edges that have the same end nodes. Okay. Yeah, I do actually know what a multi-graph is. So this would be like to use the husband and me example, we're married, so obviously that's an edge, but also we were in the same club in college, so that's an edge. And sort of like all the ways that we have a relationship would be another edge. Okay, interesting. And it looks like it can also be connected to the same node. I don't imagine we'd have that in a social network situation. So these are not acyclic. These are cyclic graphs. I mean, it's social networks are not necessarily acyclic to begin with. Actually, it would be fairly weird to have an acyclic social network. I'm trying to think of an example where that would be. Maybe like an advisee social network wouldn't necessarily be cyclic because you're not going to be advising your advisor's advisor. Yeah, anyway. Okay, so this sounds good. I like their motivation. I do want to see some discussion. Oh, I see a message and then that it was retracted. Sorry, I got distracted. But yes, please feel free to ask questions. I am happy to chit chat. All right, our work builds on two areas: social graph identification and qualitative relationship analysis. I do like to see qualitative. Most of the research within the former attempts to build ontologies of relations between individuals based on information extracted from text, e.g. social networks, dialogues, novels. Haufe et al. 2011. Mori et al. MORI 2006 try to enhance social network extraction from the web, considering a range of entities beyond just persons. They identify the nature of entities, e.g. person, firm, geopolitical entity, and their relationship, e.g. mayor of. Okay, so that's sort of like a, there's a specific term for that type of network, and I don't remember what it is, but that's a thing. That's a whole research program that a lot of people are working on. So good to see that looped in here. I think it's definitely relevant. The second area instead explores how to construct a qualitative representation of the relationship between individuals. Bracewell et al. 2011, for example, determines the collegiality between persons as exhibited in a text. So, like, do they like each other? Do they work together well? Srivastava et al. 2016 attempt to identify the polarity of relationships, cooperative or conflictual, containing conflict, between characters in narrative summaries using textual and structural features. Okay, interesting. Iyyer et al. 2016 model how the fictional relationship between two characters changes over time using deep recurrent autoencoders. I guess that's a thing you could use for that. Interesting. So I'm seeing a lot of digital humanities work. I'm seeing a lot of textual analysis. I'm not as familiar with this area, but I'm really happy to see them talking about it. Yeah, let's keep going. Nothing is popping out to me about that paragraph. Altogether, while the first field enables the extraction of complex multi-party social graphs, links representing interpersonal relationships within these graphs also often lack a more nuanced representation. Haufe et al. 2011. Okay, so the first field is social graph identification, and the second field is qualitative relationship analysis. And the reason that they're interested in both is because they want to be able to figure out the relationship for social caseworkers. So you want to know that somebody has links, and also, oh, this person like helps them out, and oh, this person is a bad influence and is, whenever they hang out with this person, they forget to do the laundry, I guess. I don't know. I'm not a social worker. Not a field I have a lot of experience on. All right. On the other hand, techniques from qualitative relationship analysis lead to a more extensive understanding of relationships, yet they are typically applied to minimal settings consisting of 2 or 3 individuals at most. Yes, it takes forever. Our work brings both fields together by producing larger multi-party social graphs with qualitative links identified between the individuals. Okay, so the specific qualities are the work that they've talked about earlier. The qualities are things like cooperative or conflictual, or like whether or not they're being collegial. So each edge has some sort of label applied to it, and there's the set of labels. Okay. Modeling relationships. We model interpersonal relationships, or simply relationships between two entities, by analyzing the list of associated relationship signals, hereafter signals, which are extracted by an NLP system. At this point, we focus on 4 kinds of signals. So these are their features. Direct speech, a person addressing another one without mentioning him, her. E.g., Phoebe to Monica, the weather is nice today. So this is if you talk to somebody. Direct reference, a person addressing another one and mentioning him, her explicitly. Phoebe to Monica, I hate you. Okay. Indirect reference, a person mentioning a third party, i.e. someone who is not present. Phoebe, I like Rachel. And then third party reference, the description by a third party of any kind of relation between two entities, e.g. Phoebe, Ross has been in love with Rachel forever. Michael says, where does this paper stand on the knowledge level sense? Advanced? Like, what do I think the knowledge of the authors is? Or like knowledge systems? A knowledge representation? Because that's like a... knowledge graphs in NLP are a whole thing. So I'm wondering if you were asking, like, do I think the authors know what they're talking about? Yes, so far I'm you know, I haven't gotten any signals that I'm like, or are you talking specifically about how they are incorporating things like knowledge graphs? I don't know yet. We will get there. Okay, so we've got 4 types of features. I talked to you about you. I talked about somebody else, or somebody else talked about us. While we focus our examples on humans, entities could also include corporations, governmental organizations, products, brands, and animals. E.g., Toyota allies with Intel in bid to overtake GM. For each detected signal, our system seeks to present a qualitative description, including sentiment, emotion, such as anger, disgust, joy, etc., other qualitative aspects such as intensity, formality, cooperative versus adversarial, along with information on the context, such as geographical location, settings, one-on-one versus group discussion, whether face-to-face or remote, whether synchronous or asynchronous interactions. Okay, so that's a lot of features. So the signals are these types of reference, and so each signal will have each of these features, or this is the feature set, and each interaction might have something among them. So my question here is, are they looking at the sentiment, emotion, intensity, formality, cooperative versus adversarial, geographical location, blah, blah, blah? Is that being tagged for every single thing, or is it only tagged, like, am I only going to tag it as discussed if I notice that it's discussed, and if I don't notice anything about formality, I'm not going to do it? I'm sure this will be discussed later. In turn, through a model to aggregate those signals together and over time, this enables us to attach qualitative metrics to relationships, for instance, sentiments and emotions, so as to differentiate between supportive relationships and negative relationships. Okay, so these sub-features are all to help figure out whether or not a relationship is healthy for both people involved, because again, we're talking about social caseworkers. But also volatility of sentiment and emotions, intensity/frequency, and recency. Granovetto observes that the more frequently persons interact with one another, the stronger their sentiments of friendships for one another. The more frequently persons interact with one another, the stronger their sentiments of friendship for one another are apt to be. Granovetter, 1973. Okay, so there's a lot of different things that they are tracking to try and determine the state of these relationships at a static time, and they're also looking at change in the quality of the relationships over time. So first off, does this relationship exist? Second off, what's it like? Third, how is it changing over time? Okay. And I'm just sort of like rephrasing as I go through to make sure that, like, I got it in my brain. The logic underneath the aggregation model can vary by situation, but is typically based on weighted counts of the various signals. For instance, in the system, in the sentence, "You, Frankie, are a liar," the system would extract at the atomic level 1 direct speech signal from the speaker towards Frankie and 3 direct references as well. Oh, I see. So the sentence is, "You, Frankie, you are a liar." And the direct references are "you, Frankie," and "you." So it looks like each word is being tagged, like each reference is being tagged. So there's going to need to be some anaphor resolution here. Like I need to know who "you" is referring to. And in this case, Frankie's name is in it. I've got this sort of like direct reference in here. But that's a potential source of error in the system. So I definitely want to see them talk about that. When aggregating, it may be that the 3 direct references are counted as 1 rather than 3, being all from the same utterance, and that the direct reference takes priority over the direct speech signal, which can be discarded. Okay. So so it could be 1 rather than 3? I get that. That makes sense because it's a single utterance. But are they modeling the utterance level or the word level? Or is this something that they're going to do in model comparison? I'm a little murky here. However, in some scenario, it may be relevant to keep track at the level of each atomic signal. Our system provides the flexibility to design bespoke models of how signals map to relationships. Okay, so they're saying their system is flexible, and you can choose sort of the level of your granularity. From an engineering perspective, we rely on Solr to index each signal with all inferred facets such as entity, sentiment, and type. Okay, so every word is going to be tagged for each of these features. Every reference word is going to be tagged for each of these features: sentiment, intensity, emotion, formality, blah, blah, blah. Solr, I am not familiar with, so let's find out about this. Apache Solr, it's Lucene, lucene.apache.org/Solr. Solr is the popular, blazing fast, open source enterprise search platform that built on Apache Lucene. I've not heard of either of these things. That doesn't mean they're not, good or they're not popular. It's just I haven't heard of them. Hundreds of features, resources. Solr is a highly reliable, scalable, and fault-tolerant, providing distributed indexing, replication, and load-balanced querying, automated failover and recovery, centralized configuration, and more. Solr powers the search and navigation features of many of the world's largest internet sites. Okay, so it's a web store. Is this a database? No, it's for search. So is it like Elasticsearch? Okay, yeah. Elasticsearch was introduced a few years after Solr. Okay, yes, so it's like Elasticsearch is what I'm getting by the fact that this auto-completed. And it looks like Elasticsearch is more popular over time than Apache Solr, but they are not contemporaneous, not equivalent, comparative. Solr is much more oriented towards text searching, while Elasticsearch is often used for analytical querying, filtering, and grouping. Okay, that makes sense. Because this is a text project, we really want to know about text search. So not previously having heard of this tool, a little bit of Googling, it seems a perfectly reasonable thing to use. And they are focused on person entities, but we haven't got to that footnote yet. Okay. Nlp Systems. This is where we're going to get to the sort of more of the technical details. And we are, NLP papers are short. We're about halfway through. And the last page is just references. So in case you were worried about time, I think I'm doing okay with my time management. Our system combines NLP tools to perform entity mention resolution and then extract signals between those entities. Okay. This is that anaphor resolution I was mentioning. So 10 out of 10, that's what I want to know that you are doing. Our entity mention resolution borrows from named entity recognition, mention detection, co-reference resolution, and entity linking. The only thing that I'm not familiar with here is mention detection. Like I can guess what it is. So named entity recognition is going through text and being like, oh, that word refers to a named thing. That word refers to a named thing. I did a live stream on that a while ago if you're interested, using Spacey. Where am I? Mention detection, I don't know what that is. Co-reference resolution is the thing that I was mentioning where like you and Frankie refer to the same thing. Anaphora resolution is another name for that. And entity linking is similar, except that it's specifically for entities. And mention detection, I imagine, is detecting mentions. ACM paper, is there like somebody's syllabus? No? Alright, let's see if I can have access to this ACM paper. I can, hopefully. Reduced version, improved mention detections to search the onto notes annotation system. I don't know why this is the first result. It is not the canonical citation, apparently. All right. Well, I'm guessing it's detecting mentions, and hopefully they'll talk about it more. Oh, thank you. Subham says Solar is a standalone enterprise search server with REST-like API. Helpful. And it makes sense that they're using an enterprise thing on account of being at IBM, which is a company, and probably not something an academic would be likely to use. I don't know. Maybe people are all about it, and I just haven't run into it before. All right. We address more than just named entities, i.e. we are interested in all person entity mentions. So if I only ever refer to my friend Frankie as he, I want to know that I'm talking about Frankie. And look at not only co-referred ones. Okay, so that's what they're saying. To get a complete picture of the connection for a person, we want to identify all possible references to them, whether named entities or not. So things like Ross Geller, Ross, and him, you, that guy, his son, and the professor, knowing that those all refer to the same person. I don't think Ross is a professor. Ross is from Friends. If you haven't watched Friends, all of these sort of examples are from the TV show. Okay. Entity mention detection. We use named entity recognition and co-reference resolution to identify mentions of entities, people, in the text and supplement that with tools for identifying common roles, professions, titles, or relations, e.g. brother or neighbor. Are you going to talk about what those tools are? Are you going to mention that? Okay. Oh, I don't think this is their repo. Do they have a link to their repo? All right, we'll find out. They use tools, question mark, question mark, question mark, to be resumed later, hopefully. We leverage social graph information to resolve the detective entity mentions. Oh, sorry, this is under the heading, entity linking and resolution. This involves, for example, making use of family relationships to find or disambiguate new mentions of entities in the text. When no social graph is provided, this step includes building a graph from a knowledge source or to bootstrap social graph creation using the output of an entity mention detection. For those cases, further named entity disambiguation might be needed. Pabico 2014, Han and Zhao 2009. Okay, so what they're saying is that once they've created their social graph, then they're going back and using that social graph to sort of fill in the gaps in the text. So not only are they using the text to create the social graph, they're also using the social graph to create the text, hence bootstrapping. Savam says, at Rachael, mention detection is a subtask of detecting the discourse status of each noun phrase, classifying it as discourse new, singleton, mentioned only once, or discourse old, occurrence. Oh, thank you. That's very helpful. I did not get that from my 2 seconds of Googling. So basically, if I'm talking about my hedgehog Gustav, this is the first time I've mentioned him today, so that would be discourse new. And then if I never mentioned him again, then it would be a singleton. Or if I talk about Gustav again, it would be discourse old. So it's like, how many times has it occurred in this, text body? Thank you. That's very helpful. He growled at me today. He was so grumpy this morning. He was like, if you disturb him and he doesn't want to be disturbed, he'll go like, choo, 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 choo. And today he went, I've never heard him make that sound. I don't think he likes that it's getting cold. I don't think he's a fan of that. He's completely temperature controlled. Anyway, okay, so they're going to do a little bit of bootstrapping. Relationship signal detection. Using the resolved entity mentions, we detect relationship signals between entities and characterize the signal type, section 3. So that's whether I'm mentioning you or talking to you or that sort of thing. In addition, we performed targeted sentiment and emotion analysis between entities. Okay, so that's just sort of like annotating the edge. Figure 1 illustrates how the different modules are articulated. The dashed arrow going from the graph-based mentioned resolution towards the text-level mentioned detection module indicates that information from the graph can further contribute in disambiguating and enriching the text-level mentioned detection steps. For example, pronoun resolution. Holy moly, that sentence was like a taffy chew. Let's look at figure 1. All right, so in figure 1, we've got 3 sort of big boxes. In the first box, we have named entity recognition, and that's feeding into pronoun resolution. And then role and relationship detection, which doesn't have any arrows. And then that whole box that has those 3 things feeds into a second box that has person graph detection, which feeds into reference by role resolution and reference by relationship resolution. And then there's a dotted arrow going back to the first box. And then that second box has an arrow going to the third box where it says interaction and connection extraction and sentiment extraction. So first we're doing the identifying of individuals. So first we're going through and we're tagging all the text, and then we're creating a graph, and then we're using the graph to refine our tagging, and then we're refining our graph using our refined tagging, and then we're using that to create our final graph and tag the edges with the quality of the relationship. That makes much more sense. Sorry, that sentence is, whew. All right, noted. The output of the NLP extraction pipeline comprises of a list of entity mentions and a list of relationship signals between those entities. Okay, classic graph stuff. These contribute to enrich our understanding of the social graph among the entities, or create one if none was provided as input. Oh, okay, so you can start with a graph if you have like partial information. From this combined information, we draw the relationship graph. Okay. Visual interface features. So this is a demonstration, so they have a complete system that they're showing to people, and this includes a visual interface. This is not, you wouldn't usually talk about a visual interface in like a research paper, but because they built a system, this does make sense. Our current system enables users to 1. Aggregate information over time over sentiment categories, 2. Visualize temporal relationships over time, and 3. Scrutinize each atomic signal underneath each relationship with the possibility of editing or correcting it. Oh, I like that. So even someone who, isn't very technically savvy, if they're using this system and they know, it was the potluck that Bernie put on that they went to and not Susan put on, and they can go through and correct that manually. I really like that, especially since I'm imagining that this is fairly lossy. I don't see any discussion of like system performance, so question mark. Supam says, it looks like a very high-level overview paper. I hope they open source code later for better understanding of submodules. Yeah, agreed. Will they? Question mark. Will IBM sell it to you at some point, maybe? I don't know. Question mark. But yeah, it is fairly high level. It's cool, though. I like the idea of bootstrapping and going back and forth between the text tagging and the social network as you're building up the social network. But I do feel like there's also the potential, if you create an erroneous link at some point in the social network, you have that, because you're bootstrapping and you're going back and forth, you have the potential to sort of like propagate and, really distort your social network based on that link that shouldn't have been there in the first place. So shrug. All right. Another task that we are considering enabling is the ability to reason over the graph, knowledge propagation, e.g. if A admires B and B admires C, it is likely that A admires C. I don't know that that's a great example. Maybe something like if A is the student of B and B is the teacher of C, then C is the student of A. I don't know. Maybe something that's more usually reciprocal, because admiration is not necessarily reciprocal. I don't think it's a bad idea. I just don't like their example. Okay. Our current interface hinges on 3 primary views. Network overview, figure 2, which provides a snapshot of the social relationships using visual cues to summarize them graphically. I like that. The average sentiment is indicated through the color of the links, red for negative, green for positive, where thickness gives an indication of the strength. The thicker the link, the more positive or negative the sentiment. Okay, so it shows sentiment, but where's the rest of their tags? They had like 80 features. The UI supports visualizing the network as an overview or over specific time intervals. That's really nice. Next version will include a representation of intensity through dashes, along with an indication of volatility by replacing the line with a sinusoidal curve. So if the relationship is volatile, the line will be wavy. Recency will be captured through the placement relative to the ego node. People who are more recently interacted with the person are closer. So here's sort of like the way that it looks now. I'm gonna zoom in even more. This is my biggest pet peeve. My biggest pet peeve is these tiny butt screenshots in papers. And if I'm reviewing your paper and I see these tiny, tiny little hard to read screenshots, I will definitely mention it in the review. I won't necessarily like downgrade you, but it's hard to read. Okay. So we have here a network, and it is a multi-graph. Oh, it's directed. It makes sense that it's directed, but I don't think they ever mentioned that it's directed. So we can see Barry's relationship to Ross and Ross's relationship to Barry. And it looks like sentiment and strength is reciprocal across both directions. So Phoebe and Carol and Phoebe has a relationship to Carol and Carol has a relationship to Phoebe. And the sentiment is the same intensity and direction for both people. If you're gonna do a directed graph, I feel like you should not necessarily make it reciprocal, or maybe it's just these particular characters, but I want the possibility in a thing like this to have like a strong negative relationship between Phoebe and Carol, but maybe Carol actually kind of likes Phoebe a little bit, so like more of a it would be probably green for positive, like a thin green line here. And again, maybe it's just their training data, but I don't love this. Yeah, maybe they'll talk about it. And I'm fine with it until they, like I'm fine with them not having that, but if they're gonna have directed edges, then I want the directed edges to like really speak to the directionality of the relationship. So I think that is, if I were reviewing this paper, that's definitely something I'd mention. Yeah, I like these though. I really like the recency being captured by spatial relationship. I think that's interesting. That's a nice visualization. So that would be the length, the edge length. The downside of that, sort of from a visualization perspective, is that if I'm really close to someone and I have a strong relationship and I react to them or interact with them a lot, then that edge is going to be shorter. So I won't have as much space on the edge to see this visual information that they're including. I also don't like the red-green distinction. That's not very colorblind friendly for polarity. I get it, it's very intuitive and we do it for a lot of things, but since you're talking about your visualization, it should be nice. Not that it's not nice, there's just like some tweaks I'd make. All right, the personal network view, figure 3, supports the view of the 2-hop interpersonal relationships. So like friend of a friend. Scroll, of the individual, along with a summary view. I'm gonna zoom in a little bit so I don't have to scroll back and forth. Of the person in terms of general emotions expressed. Donut chart in the bottom right quadrant of the screen. The view can show the overall sentiment and intensity of how they interact with others. That's, okay. So this is, we're looking at Ross. Oh, let's zoom into these tiny figures. And I've lost my bottom bar, so I can't scroll over. There we go. Scrolling with the mouse. So we can see that Ross overall is mostly joyful, sometimes sad, sometimes fearful, less often anger, less often disgust. And they're using both thickness and radians to show this, which makes me wonder if the proportion is volume, or is it distance from the center of the donut, or is it radians? So I'm just confused about, like, is disgust like a third of the amount of joy, or is it like a tenth of the amount of joy? I'm a little bit confused by this visualization in terms of getting out strength. And I think this particular thing only really makes sense in the context of something like social work, for something, because, like, if you have very strong positive relationships with some people and very strong negative relationships with other people, which is like a thing that people do, then you're gonna have like a weird looking donut. Like, your donut's gonna just be like, oh, this person's very neutral, even though you have lots of strong positive and strong negative relationships. So I guess in the sense of social network, you want to know that people have like some positive relationships, and you don't necessarily want to see like all anger all the time. But I don't know about this donut. Zoom in a little bit. It is very slick. Like, it looks very nice, but just in terms of data visualization, I don't know about some of these choices. Excuse me. Yeah. I don't know. That seems just like too high level of a thing. Finally, the relationship view, figure 4, consists of a stream graph presenting the 5 primary emotions, anger, disgust, joy, fear, and sadness, as they change over time. It can be used to see the intensity of the relationship either by type, sentiment, or emotions. Drill down support is provided where the user may hover over peak areas of interest in the graph to inspect the snippets of text from the input corpus that support the inferred emotion. Okay, so if it says, oh, you're angry with Gustav, I can hover over it and be like, oh, he growled at me. Okay. The emotions are directional, where the upper part of the stream graph represents the signals from entity X to entity Y, and the lower part of the graph represents entity Y to entity X. Okay, so they have like directional stuff. It just, okay. So perhaps the reason that these look reciprocal is because the relationships are fairly reciprocal. And this might also be because I'm guessing that the text data that they're using is scripts from television shows. Also, they don't talk about which data they're using, which I'm not a huge fan of that, but I'm guessing they're using maybe scripts, maybe summaries from like a TV guide or something. Yeah. Oh, that's something I didn't mention. They mentioned that they're using speech input, and I imagine transcribed speech, right? Scroll. What is your input information? Yeah, case notes, speech transcripts, posts, and books. If you are using speech transcripts and they are not done by hand, you are likely to have very systematic errors in them that might, just like throw off the whole thing. So that's something to think about, especially for especially for folks who aren't well represented in speech corpora and training corpora. So like white people living in New York City, fairly well represented. They're weirdly like upper middle class, despite the fact that I think like most of them are waiters. I don't know. Friends is weird. But it's very standardized, very educated sounding language. Yeah, which is more represented in speech corpora than language from people who have different experiences. And everybody should have technology that works for them if they want it. Okay. This I like much better than this. I think this is a really nice description and very helpful. Assuming that you have so they also have very well-spaced time points. So I wonder how they deal with things like temporal sparsity. I don't talk about that. Like Subham mentioned, it is a very high overview level paper. All right, demo flow. Ideally, we would have relied on anonymous care worker notes to demonstrate our system. However, privacy restrictions. Oh, here they talk about data. I retract the things I said where I was like, they didn't talk about the data. They definitely did. Ideally, we would have relied on anonymized care worker notes to demonstrate our system. However, privacy restrictions made access to such notes challenging, and for our proof of concept, we have used transcripts from the Friends TV series, whose theme, i.e. the interactions among a core group of friends, is well aligned with our objective. We specifically focus on the first 2 seasons and leverage character identification corpus created by Chen and Choi 2016, which includes entity annotation of personal mentions. Okay, so this is high quality data, what they got. Is this an LREC paper? Oh, it's not linked to the publications. Chen and Choi. It is a ACL paper. SIGDAL. Okay. I would have put that as a... Well, no, that makes sense because it is on English. Okay. Sorry. LREC is the big... I have a corpus conference that people go to, and it's also every 2 years. So I think there was one this year in like Singapore, maybe, so it's not going to be for a minute. A natural starting place for an analysis is the messy social graph for all characters over all episodes of Season 1. Figure 2 shows the overall social network when narrowing down to Season 1, Episode 2. From this place, a user can further dive into one specific character, selecting a node, or rather explore a relationship, selecting a link. An edge. A link? Do people say link instead of edge? I definitely say edge. Shrug. Assuming the user selects to focus on Ross, then his personal network view would be displayed. The dominating emotion conveyed in this episode is joy, both in quantity and in strength, represented through length of the arc and radius respectively. Represented through both? So it's not volume. But the fact that it is... Okay, so earlier when I was like, is it this that shows us the quantity or this that shows us the quantity? It's both, but since you're using both, it looks like volume. Manikandon asks, can you share a link to the paper? Yes, there should be one in the video description. And it is also, if you Google the title of the paper, Understanding Social Connections from Unstructured Text, you should find it. It's ACL papers are all open access. Yay, open science. So anybody should be able to get it if you have an internet connection. Which presumably if you're watching a YouTube video, you do. Okay. Assuming the user selects to focus on Ross, then his personal... blah, 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 blah. I already read that. In this episode, Ross learns that from his now lesbian ex-wife Carol that she is pregnant with his child. In terms of relationship, the graph shows mostly negative sentiment towards other characters, especially Barry, though positive ones towards Rachel. Oh, and the link is to the, this GitHub link is to the corpus of entity annotations of friend scripts. Selecting a relationship, e.g. the one between Ross and Rachel, this user will be shown a stream graph as in figure 4. This graph shows the 5 primary emotions as they change over time during the series. The x-axis represents the progressive episodes numbers, and the y-axis the intensity of the emotion. Above the x-axis is the relation Ross towards... Above the x-axis, the relation Ross towards Rachel is shown. Below, the relation Rachel towards Ross. We can observe the distinctive asymmetry of this relationship. Which is true, they are fairly asymmetrical, especially right around here and right around here. For instance, in episode 11, there is no specific emotion from Rachel towards Ross, though a mix of emotions expressed by Ross towards Rachel. In this episode, Ross is jealous of Rachel's boyfriend, Paolo, and confides his feelings and love troubles towards Rachel to Chandler's mother. In episode 16, the sentiments of anger, fear, and disgust are present in Ross towards Rachel, but not vice versa. As part of the actual demonstration, we will challenge users with a sort of information retrieval task aimed at illustrating the types of questions that our approach supports. For fact-based questions, we will give participants a set amount of time, i.e. 2 minutes, and will maintain a leaderboard of the fastest information finders with participants' consent. Sample questions would be, whose mother did Ross kiss during season 1? Or, how long did Rachel go out with Paolo? For questions that require interpretation, e.g. does Chandler like Frankly, we would let participants tell us their opinion before and after using the tool and ask them if the system was helpful in gaining confidence about their final answer. okay, that sounds fun. I kind of wish I'd been there. I wish I'd been at NACL, but I had other things that I had to be at. So this is like super nice technical writing to describe how to use the system. I'm a fan of that. I am not getting a lot of technical details. I would like more, because so they mentioned like a bunch of features. They mentioned things like formality. They mentioned things like intensity. I'm seeing intensity represented here by strength. I'm seeing sentiment. I'm seeing emotion. But there's a bunch of stuff that they said that they tagged for that they didn't include in the visualization, which I'm a little bit like, it's fine, but then why did you tag for it? Like, is it just not done? Were you just trying to get in by the deadline? Which, yeah, I mean, we've all, if you've ever submitted a paper to a conference, like the deadline comes up fast, and we're all busy, and I get it, but it is a little bit like, you told us we could have this thing, but where's this thing? Conclusion. This paper presents a system to support the analysis and understanding of interpersonal relationships. Relationships are described along multiple quantitative and qualitative dimensions, which are automatically populated from relationship signals extracted from text by an NLP system. The associated interface enables a user to quickly focus on a specific person or pair of persons and to investigate how the relationship evolves over time, which, as we just found out. Okay, overall, really cool, interesting system. I think it has a lot of potential to be very useful, especially for people doing things like field work or like caseworkers. I think is a really good example. But some things that are putting up my little warning antennas a little bit. They mention in applications, and I mentioned this at the beginning of the string, they mention in the applications criminal investigations, political analysis, human resources, and I am a little bit worried that they don't have any discussion of potential ethical implications. And I mean, obviously this is an enterprise paper, so, or a paper from industry researchers, and obviously there's restrictions on what you can talk about. But I would be a little concerned if we were using this to identify suspects and people who they have a close relationship with, especially given that they are using speech input. And as I mentioned, like, we know that in the US, automatic speech recognition is just not as good for Black people. It just has more errors. Or I should say people who speak African-American English. We know that it's not as accurate for, well, we don't. I have a strong hypothesis that I don't have the data to support that it's not as accurate for people of lower socioeconomic status, and people who, don't have a college education. Not that there's anything wrong with that. Not that not being college educated is what makes the system bad. It's the fact that we have an overrepresentation of college educated white people in our corpora. If you ever looked at like Switchboard, it's pretty white. And when they have socioeconomic information, it's not great. So worrying. I also didn't see any discussion of performance. They just sort of presented the information that the system extracts as ground truth. Is it? And I'm not gonna like be like, oh hey, it's maybe kind of a problem that you didn't talk about the performance of your tagging system, because they used pre-tag data. So that's not part of their contribution. But do we have like human ground truth for any of these relationships? Like, this is unsupervised learning, of course, but I would still like to see comparison to something, right? It's just sort of like, our system does this, which is great, but I don't know how good it does it, right? Yeah, so that's something that I'm a little bit, and there's also a lot of details that are sort of like tantalizing but not discussed in depth. So looking at these features, there's a lot of features that they were tagging for, right? And we don't see a discussion of all of them. So sentiment, emotion, these are already shown in their visualization. And they talked about how they'd show some of the other ones, but things like formality, like did you tag for it and you just didn't show us? Geographical location, that's super interesting. There was zero discussion of it. They mentioned that they look at it here and then like, what do you do with it? How are you getting it? Where does it go? The sort of like one-on-one versus group discussion, really interesting, like dyads versus like tetrads or whatever. It would be great to automatically identify this, especially in speech transcripts, especially in automated speech transcripts. That would be amazing, but we don't have any discussion of it, so I'm a little bit like question mark. Face-to-face remote, like, again, really interesting. This is like, each of these things is like a whole paper in and of themselves that I would really love to dig into, but we just don't have the deets. And then synchronous versus asynchronous, again, super interesting. So synchronous is something that's happening sort of in real time. So if this is synchronous, right, where we're talking back and forth. Asynchronous would be like if you email somebody and then later they email you and it's happening at different times. So these features are super cool and interesting, and I would love to learn more about them, but they're just not discussed in any depth. Also, the system diagram is like, how are you getting the person graph? Like, how are you extracting this person graph? I can sort of like guess what it might be like, because you're detecting these roles and relationships, and then you're just sort of like creating a graph from there, but reference by role resolution and reference by relationship resolution. Like, I don't know what the difference between these is. Did I just miss this? Role resolution. Nope. Do they mention role? Vital role, disruptive role. Okay, we use named entity recognition. Supplement that with tools for identifying common roles, e.g. professions, titles, or relations. So they are tagging each person in addition to their relationships between these people. They're also tagging them with like doctor. And like, I don't know where that's going. I don't know. I get the sense of like a duck here, right? Like there's a lot going on. Like the duck looks serene, just like going across the surface of the pond, and then underneath the legs are just like going wildly, and we just like don't know what the legs are doing. Like this is more or less a black box, which I don't necessarily have a problem with a priori, but I do want to see more information. It is cool work. I'm super glad they shared it. Really interesting. I'd be really interested to see more evaluations of this system. I'd be interested to see where they go with it. And again, this paper was from this year. This is fresh. This is hot off the presses. Yeah. So interesting paper. I think a cool idea. I don't think it's bad work. Like I think sometimes, especially in class when you're discussing a paper and you bring up like a lot of like little criticisms, people are like, oh, there were a lot of criticisms, the paper was bad. No, that's not the case. I'm not dunking on this work. It's good work. But I do want to know more. I think that maybe I don't know if you can have a long paper for demonstrations, but at ACL conferences you can have short papers, 4 pages, or long papers, which are 8 pages. And I think this should have been a long paper, because I'm seeing a lot of like room for additional details that we're just sort of not getting right now. But yeah. Okay, so we read the whole paper. It has been almost exactly an hour. Good job, Rachel. Yeah, this was fun. This is, again, I have just like a whole stack of papers that I want to read and I just don't have time. So this is sort of like a nice selfish thing for me that I get to read papers and also still be doing work for my job. So if you guys enjoyed this, let me know and maybe I'll do it. I also like having a morning stream because usually I'll be streaming tomorrow afternoon. And it's nice to have a little bit of balance there. All right. Thanks for joining. If you want to find the paper one more time, it is scroll. Know Who Your Friends Are: Understanding Social Connections from Unstructured Text by Delaris et al. Or Delaris, maybe, et al. I don't know. I don't know how to say your name. I'm sorry. And it was at NACL HLT 2018, and it was a demonstration. All right. I will talk to you guys later. Thanks so much for joining me. Oh, sorry. Subham says, Deep Learning Papers Reading Roadmap. I will check that out and think about it. All right. Bye, guys.